Dear learners, in this lecture we will discuss about the topic UMTS, Universal Mobile Telecommunication System. So UMTS is the recent telecommunication standard systems, so which is comes under the category of third generation communication systems. So in these systems we can able to provide seamless telecommunication services with enhancement in quality, data rate, reliability, connectivity, system interfaces, adaptability. Yes. So as per our syllabus, we will discuss about the topic UMTS Terrestrial Radio Access Network Overview. So which is abbreviated as UTRAN. So UTRAN is abbreviated as UMTS Terrestrial Radio Access Network Overview. In general, this UTRAN consists of set of radio network subsystems. So here I have shown that RNS which is abbreviated as radio network subsystems. So in general, this UTRAN logical architecture consists of set of radio network subsystems. The radio network subsystem has two main logical elements. So here they have mentioned that two logical main elements are there. One is node B and radio network controller RNC. These are the two main logical elements which is present inside the RNS subsystem. So these two play a vital role. That is node B as well as RNC. So in upcoming slides we will discuss about what is the responsibilities of each each element, that is node B and RNC. So the general logical architecture of Utron is it consists of set of radio network subsystems. In each radio network subsystem, it consists of two main logical element. One is node B and another one is radio network controller. Right? The connection between core network and RNC is IU, which is abbreviated denoted as IU, and the connection between RNC and node B is abbreviated as IUB, and the connection between RNC and RNC is denoted as IUR. So in order to understand the logical architecture, here I have shown some pictorial representation. So in which the first thing is major user equipment. The user equipment, you all know that whatever we are using our devices, that is called as user equipment devices, in which will be placing the SIM card. Based on that only we can able to confirm our authority. So then only it can able to make the connection to the node B, and node B is responsible to provide the frequency link to the required users, and all those things taken care by this UMTS architecture. So these are all these things taken care by the RNS system, which is comes under the category of UTRAN. So first we will discuss about the first logical element, radio network controller. So here the radio network controller is there. So the main responsible of this radio network controller is it can control the radio resources of node B's in its domain. So it can control more than one node B at a time. So the primary responsibilities of an RNC are intra-uterine handover, macro diversity combining, frame synchronization, radio resource management, outer loop power control, and IU interface user plan setup, and SRNS relocation, IUB user pin protocol determination. These are all the primary responsibilities which is done by RNC. So the main aim of this RNC is it can able to use and allocate all the radio resources of the RNS. So those who are all require belongs to this RNS. Then the main aim of this RNC is to allocate the radio resources to all the user which is belongs to the corresponding RNS. Next, another logical element is node B. The primary responsibilities of Node B are termination of IUB interface from RNC. If it is not required, it can able to terminate. Likewise, it has to terminate the MAC protocol for transport channel RACH and FACH, and it can also terminate RLC and RRC protocol for transport channels and radio environment survey and inner loop power control, open loop power control, RF processings, modulation and demodulation. All those things can taken care by this node B. Then we will discuss about Utron logical interfaces. So in this thing, in Utron logical interfaces, here the Utron protocol structure is designed so that layers and planes are logically independent of each other. So here the layers and planes are logically independent of each other. This protocol contains two main elements, that is radio network layer and another one is transport network layer. This consists of two main layers, radio network layer and the transport layer network layer, which is abbreviated as TNL and RNL. So when we look into the RNL, here the application protocol, here two planes are there, one is a control plane and another one is user plane. The control plane here is used for all UMTS specific control signaling. So it includes the application protocol. The application protocol is generally used for setting up bearers to the user equipments. And another layer is transport network layer, which is abbreviated as TNL. So in transport network layer, the control plane carries all control signaling within the transport layer. It does not include radio network layer informations. It contains access link control application part, which is abbreviated as ALCAP, access link control application part, which is required to set up the transport bearers for the user plane. It also includes the signaling bearer needed for the ALCAP. The plane lies between the control plane and the user plane. Next, we will discuss about IU interfaces. So while seeing the architecture itself, we know that IU interfaces, which is the connection between core network and to the radio network controller. The IU interface in UMTS, the IU interface is the open logical interface that interconnects one neutron to the UMTS core network UCN. Right? The IU interface is terminated at the RNC and at the UCN side it is terminated at UMSC. So mainly it consists of three protocol planes. One is radio network control plane and another one is transport network control plane and third one is user plane. Here the control plane serves two domains in the core network. One is packet switched domain and another one is circuit switched domain. Here we will discuss about the packet switched protocol architecture on IU. The here the PS are abbreviated as packet switched protocol. So when we compare with packet switched and control switched protocol, here the major variation we can notice in transport network layer. So this is a PS protocol and this is CS protocol. When we look into the transport layer network layer in PS protocol, nothing is there in transport plane, but in control, so the circuit switched protocol under the transport plane, so many sublayers are there. So here the transport plane play a vital role in circuit switched packet protocol, because in packet switched and the circuit switched, um, the rearranging can take place in circuit switched network, so that the transport plane play a vital role in circuit switched protocol. And next we will see about IUR interface. So it generally provide the connection between two RNCs. So it is usually in soft handoff scenarios when different macro diversity streams of one communications are supported by node B that belongs to different RNC. And another thing is UU interface. UU interface is the radio interface between a node B and one of its user equipments. So each and every interface having the responsibilities, whenever it want, it can provide the connection, otherwise it will be terminating the interface between the corresponding devices.